Right, welcome. Ajax solution. This is matrix. So today we are going to deal with a relationship between the matrix and its adjoint. So we are saying A times the adjoint of A is equals to determinant on this leading diagonal from the top left corner, and we are having zeros here. So in general, we are just saying if we factor the determinant here, we are going to be left with the identity matrix. So A times adjoint of A is equals to determinant of A times the identity matrix here. Or you just have a matrix with the determinant on the leading diagonals here. Alright, so this is what you need to know here. Alright, so let's go here. Given that A is equals to 3, 2, minus 1, minus 4, 8, 4, minus 1, 2, 3, and B equals to minus 2, 1, minus 2, minus 1, minus 1, 1, 0, 1, minus 4. Alright, so find AB, hence find the inverse of A here. Right, so let's go here, finding AB. So A times B is multiplication row by column. So if you multiply A and B, we are going to have this matrix. So just have to let's just emphasize on multiplication of our matrix here. So we are saying multiplication is row by column. So this first row here, you can see is multiplying with this column. So this will give us 3 times minus 2. This is 3 times minus 2. Then plus 2 times minus 1 here. Then minus 1 times 0. So this is the answer here. Then this row again, the second row, let's just take the second row. The second row with the second column here, you can see it's minus 4 times 1, which is minus 4 times 1. Then 8 times minus 1, so it's 8 times 1 minus 1. Then 4 times 1 here. So that's the second row in the second column. So this is the element here. Right, so this will give us minus 8, 0, 0, 0, 0, 0 here. So you can see we now have a matrix with leading diagonal with minus 8, minus 8, minus 8 here. So which means A and B are related in such a way that A is the matrix and B is the adjoint of A here. So which means if we want to find the inverse, it becomes very easy here, because now we see that our determinant is minus 8. So the inverse of A is equals to 1 over minus 8, which is our determinant. Then the adjoint of A here, we see it clearly that the moment we multiply A with the adjoint here, we get the matrix with the determinant on the leading diagonal here. So which means the adjoint will be B here. So the inverse of A is 1 over minus B times B here. So take note here, A times the adjoint of A, we have a matrix with the determinant on the leading diagonal. Then the other elements will be 0 elements. Right, so let's go to the next example here. Alright, given that Q is equals to this matrix, find Q inverse. So we can use this concept of multiplying the matrix with its adjoint to also find the inverse. Right, so in this case, we are going to first find the adjoint of Q. Right, so finding the adjoint of Q, we can start by finding the cofactor of Q here. Right, so finding the cofactor of Q is very simple. We can have the matrix of minor first. So matrix of minor, if you haven't watched the video, go and watch the video on finding the inverse. You understand how to find the minor. So we are going to find the minor of 1, the minor of 2, the minor of minus 3, the minor of 4, the minor of 3, the minor of 2, the minor of 1, the minor of minus 2, and the minor of 4 here. Then that's the matrix of minor. Then to have the matrix of cofactor, we are going to multiply with these corresponding signs, which is plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. Then we have we are going to find the determinant of 2 by 2 matrices here. So this is determinant here, it's going to be 16. Determinant here is going to be minus 14. Determinant here is minus 11. Then determinant here is minus 2. Determinant here is minus 7. And here is 4. And here is 13. And this one is minus 14. And this one is minus 5. So that's the matrix of cofactor. Right, so we now have the matrix of cofactor. We need to find the adjoint. So the adjoint is given by transposing the matrix of cofactor. So we are going to transpose. So to transpose is to just interchange the rows and the columns. So we interchange here. So this is the adjoint of Q here by interchanging the rows and columns. So you can see 16 minus 14 minus 11 becomes the column here. So it's 16 minus 11, 16 minus 14 minus 11, then minus 2, minus 7, 4. It becomes it was the row, it becomes the column. So it's minus 2, minus 7, 4. Then 13 minus 14 minus 5 was the row. So it becomes the column. 13 minus 14 minus 5 here. So now we have the adjoint here. So we know that if we multiply Q, the matrix Q, and its adjoint, we are going to have the determinant on the leading diagonal, and the elements will be zeros, right? So let's multiply Q and its adjoint here. So we are going to multiply Q times the adjoint here. So Q times adjoint is row by column. The first row multiply with the first column, first row, second column, then the first row again with the other column here. So this will give us 21 in the leading diagonal here. So you can see 21 from the top left corner to the right bottom corner here. So this is 21, and the other elements are now zeros here. So this is now our determinant. So our determinant here clearly is 21 here. Then now we can now find the inverse here. So inverse is 1 over determinant. So it's 1 over determinant, which is 1 over 21 times the adjoint of A. So the adjoint of A already we find it. So this is our inverse. All right. So we can use this concept when you're finding the inverse. So the first thing, you find the matrix of cofactors, then you find your adjoint, then after finding the adjoint, you multiply Q with the adjoint of Q, then you can have your matrix here, then you have your determinant at the leading diagonal, then you can write the inverse. Right, so thank you for watching the video. See you in the next lesson.